All right, so we want to find the area of the shaded region. Um, Recall that when we have a function and we want to find the area between the function and the x-axis from a to b, then the area can be found by integrating the function from a to b. So to get the area underneath the curve from x equals a to x equals b, we would carry out this integration. Now over here, the area of the shaded region in green is actually above the curve. But notice that it's equal to the area that we want. It's equal to the area below the curve. So maybe I'll call this area in green, I'll call it A1. Um, if we integrate the curve, if we integrate 1 plus cosine of x from 0 to pi, what we always get is the area below the curve, between the curve and the x-axis, like we've pointed out over here to the right. So what we would get here is actually this area right here, which maybe I'll call a sub 2. But if you look at this figure, notice that a sub 1 and a sub 2 are the same. So if I carry out this calculation, the integral 1 plus cosine x from 0 to pi, this will be what I want. It'll be the area of the shaded region. Okay, so the integral of 1 is with respect to x is x, and if I integrate cosine x, that'd be sine of x. And now we have to evaluate this from 0 to pi. And so we have pi plus sine of pi minus 0 plus sine of 0. Sine of pi is 0. And the sine of 0 is 0, so the answer is pi. So the area of the shaded region, the answer to this problem is pi. Sometimes, we don't even need calculus, though, to get the area. Notice that the area in green is actually just simply half of this rectangle that I'm outlining. The area that we want, a sub 1, again, is just half of this rectangle. And whenever we have a rectangle, the area is length times width, and the length of that rectangle is pi, and well, the dimensions are pi and 2, right? This dimension, horizontal dimension is pi, and the dimension up and down is 2, and so the area of the entire rectangle is 2 pi. But the area that we want, the area of a sub 1, is half of that. And so a sub 1 would be half of 2 pi, which is pi. So for this particular problem, we could actually use calculus or geometry to have gotten the answer. Right, so here we want the area of the shaded region. There's actually 2 shaded regions, so we're going to have to find them each and add them together. Let's see, I'll call this area a sub 1, and this other area I'll call it a sub 2. So I got to find a sub 1 and a sub 2 and add them together. To get the area in between 2 curves, we have to subtract the curves. And to do that, we need to know where they intersect at. It looks like they intersect at x equals negative 3, x equals negative 2, and x equals 1. Let me switch colors here. This point right here that I'm marking in purple, it looks like it's negative 2, but maybe we don't know for sure. We want to confirm it's negative 2. So to figure out where they intersect at, we have to take the curves and equate them. So I'm taking the one curve, x squared minus 4, and I'm going to set that equal to the other one and solve this equation. If I add x squared to both sides, and then I move the negative 2x to the left, so I got 0 on the other side, I can divide the equation by 2 and factor and I got negative 2 and 1. So these two curves intersect at x equal negative 2 and x equal 1. Based on this point right here, the 1, negative 3, I can see they intersected at 1. And again, it sure looked like this other intersection point was negative 2 based on my eyes, but I've got confirmation algebraically that they intersected negative 2 and 1. All right, so to get a sub 1, we have to integrate from the left point of intersection negative 2 to the right, and then we subtract the two curves. It doesn't matter what order we subtract them in, but it's a little bit better to take the top curve. And so the top curve is the one in red for a sub 1. So I'm going to take the top curve, negative x squared minus 2x, and subtract the other curve. And whatever this comes out to be, again, will be a sub 1. So we have negative 2 to 1. I'm going to combine like terms. Negative x squared minus x squared, that's negative 2x squared. And then I have negative 2x and plus 4. Now I have to integrate each term. So we have negative 2/3 x cubed minus x squared plus 4x. And now we have to evaluate this from negative 2 to 1. So first we plug in the top number. So if I plug 1 in to all the x's, I'll get negative 2/3 minus 1 plus 4. And then now I subtract and plug in the bottom number. So it's going to be negative 2/3 times negative 8 minus 4 minus 8. All right, so we have negative 2/3. Negative 1 plus 4 is 3. And then I have minus, let's see, 16/3. And then it looks like I'll have, negative 4 and negative 8 make negative 12. But if I distribute this negative sign, that'll be a positive 12. Negative 2/3 minus 16/3 is negative 18/3. And then the 3 plus the 12 is 15. And so we get negative 6 plus 15, which is 9. So a sub 1 is 9. But of course now we need a sub 2. To get a sub 2, we don't have to reintegrate. We've already integrated. I just have to switch out the limits. So we can start at this spot right here and just switch the limits. So we have negative 2/3 x cubed minus x squared minus 4x. And if I have to evaluate it, for a2, it ranges from x equal negative 3 on the left to negative 2 on the right. So now I've got to plug in negative 2. So that'll be negative 2/3 times negative 8 minus 4 plus 8. It looks like I made a typo. I'm glad I see it right now. Looking at over here, it's a plus 4x, but I see I wrote a minus 4x, so that should be a plus sign right here. Looks like I just copied it wrong. I see a plus sign there, so I fixed that. And when I put negative 2 in, this should be a minus 8 right here. And then now we subtract, and if I plug negative 3 in, I'll get negative 2/3, negative 3 cubed, that's negative 27, minus 9 minus the 12. Okay, so I have 16/3 minus 12. Let's see, it's going to be a negative, and then 2/3 times 27 is 18, right? 3 goes into 27 9 times, and then times the 2 is 18. And then negative 9 minus 12 is negative 21, but the minus sign distributes, so that'll be a positive 21. And so we have 16 thirds. Negative 12 minus 18 is negative 30, plus the 21 makes negative 9. And so 16 thirds minus 27 thirds is negative 11 thirds. All right, and a negative number was expected because if we look at a sub 2, the blue curve is on the top, but when we did the original subtraction to get this over here, we took the red curve for a sub 1, but but to get a sub 2, it's like we talked about in class, it's not really worth it to re-subtract the curves in the different order. All we have to do is make the number positive. So the area of a sub 2 is positive 11 thirds. So the total area, you have to add the two areas together, it'll be 11 thirds plus the 9. And I'll go ahead and turn 9 into 27 thirds. And so it looks like 38 thirds square units. That's the total area of the shaded region.